Okay, so we have seen in part 1 simple harmonic motion. Let us now start the second part. This deals with the understanding of what is a wave. Let us begin. Now, any medium we know has particles. They are the atoms or molecules. And for some reason, if we apply any external force, then the particles start vibrating. Now, in a medium, let's say if you have water. So if you have water and if I throw a stone down in the water, then we see the ripples moving around. So there is a wave formation all around. And then we see the wave traveling like some circular structure. We'll come to that later. Right now let us understand first what is wave exactly. These are, by the way, called wave front. So particles vibrate, and when particles vibrate, they transfer energy to next adjacent molecule or neighboring molecule. Okay, molecule or atom or particle, anything. Now the energy is then carried from one point to another, from one point to another. These type of motions where the energy is carried from one point to another, this is known as a wave. And all these happen because the particles get displaced from their original position. Okay. Now there are two things here. One is the direction of vibration, or it is also called oscillation, and the other is the direction in which the wave travels, which is called wave propagation. And on the basis of these two concepts, the direction of oscillation and wave propagation, we have two types of wave. And both the waves, because the energy is traveling from one point to another, they are also called traveling wave. So energy is carried from one point to another. Okay. Now let's proceed to the next part. What are the two types of waves that we would like to know? The first one is called your transversal, and the second one is called your longitudinal. So let us start first with transversal. What is a transversal wave? It is a type of wave where the particles vibrate or oscillate, let us say in this direction, the vertical, and the wave then propagates in this direction, that is the horizontal. So the wave goes this way, you see, and the particle vibrates like this. So the angle between both is 90 degree. Now when the oscillation is perpendicular to wave propagation, it is known as, or these type of waves are known as transversal wave. For example, you can tie a rope. You see, this is a rope, okay? This is a rope, and then you vibrate the rope up and down, and then you will get a wave going towards the fixed position. This is the fixed position. You can see this also in electromagnetic wave, where you have, it's a three-dimensional. So you have your electric field oscillating this way, and you have your magnetic field oscillating this way. Okay, so this is electric field, this is magnetic field, and both are perpendicular to the wave propagation or the wave direction. So wave is moving this side, propagation. So these are all example of your transversal. Okay, now what are the different aspects of a transversal wave? Let us understand that. So when a wave is traveling, let's say it goes this way, then this is known as, the height of that you see is known as your amplitude. Okay, this peak, top, positive side, the positive displacement side is called your crest, and this is called your trough. Now if I am measuring in terms of time, then the time taken for this one oscillation is called your time period, and after this we are going to understand what is the speed of this wave, and the distance covered by a wave in t, the time, which is time period. This is your time period, by the way, here, time period, is known as wavelength, and is represented by the symbol lambda. So if I need the speed of this wave, all I need is distance by time. The distance that it is covering in one oscillation is lambda, and the time it takes in one oscillation, which is the time period, is t. We also know that 1 by t is nothing but the frequency, so it becomes f lambda, and this is because your frequency is 1 by time period. So your v is then equal to f lambda. This is called the wave equation. You have the unit for frequency, which is actually number of oscillation by time taken. Here it is one oscillation, time taken is time period, so I wrote 1 by t, and the unit of this is hertz, or use the small letter hertz. Okay, now let us come to the next part. First one is transversal, now comes longitudinal. Now in longitudinal, both the oscillation and wave propagation are on same direction, something like your particle is vibrating this way and your wave is moving this way. This has a best example, which is sound, but then sound travels a little differently. See, so when we say a word hello, the moment I say the word hello from my mouth, the particles near my mouth start vibrating and then they get compressed, whereas the next set of particles are actually in the normal stage. after some time these particles transfer the energy to next one, and then you get here normal, the particle expanding actually, not normal, and then you get this compression here. Okay, so I'm sorry, this is not normal, we will call it as compression and rarefaction, something that expands. Okay, so and then again the next particle here is, so again this compression will transfer the energy, and that is how the energy keeps transferring. So we show it something like this: compression and then rarefaction, and then we get the compression and then we get the rarefaction, again we get the compression, again we get the rarefaction, again we get the compression, again we get the rarefaction. See, compression, rarefaction. So C stands for compression and R stands for rarefaction. This is how sound travels, and the wave is traveling this side. The particles are vibrating like this. See, they vibrate this way. So it is a longitudinal wave. Okay, in the next class we will understand what is a wave front, and then we'll proceed with the 4.2.